Hey, you guys, this is Mrs. Allday. We are starting week 2 of our remote online learning for Algebra 2 General Child's High School. We're starting with section 7.1, which is a new chapter, chapter 7. We're going to do exponential functions today. So if you went online and you went ahead and downloaded your notes, you should have printed out 4 pages. We're doing 2 pages today. That's going to be part 1. And then we're going to do 2 pages tomorrow, and that's going to be part 2. So let's review a little bit about what an exponent is. If I put 2 to the 2, you know that that 2 is the exponent. And that really means 2 times 2, which is 4. So if I did 2 to the 3, 3 is the exponent. And that means 2 times 2 times 2. 2 times 2 is 4, and 4 times 2 is 8. So another name for exponent could be power. So these are going to be problems where we are going to be using exponents. All right, so that's the first thing. Now, when we're doing an exponential function, it's a function that has a certain form. So this is what the form is. Write this form. Y equals A times B to the X. It's written right here, but if you write it, you'll get more familiar with it. Now, in the exponential function, A cannot be equal to 0, because if it is, and you multiply 0 times your b to the x, it's going to be 0 for every problem. So A cannot be 0. That's one criteria, or exception, or limitation, we should say. B is the base. Okay. B cannot be equal to 1. Because if B was 1, and let's say X was 1, that would be 1. If B was 1 and X was 2, that would still be 1. If B was 1 and X was 3, that would still be 1. And so you wouldn't ever have a new problem. It would always be the same problem. And that's not the way it is. All right, so B cannot be 1, it cannot be equal to 1, and A cannot be equal to 0. All right, let's talk a little bit about this X up here. The X is the exponent. It is also the independent variable. It's the input. It's the domain. The domain is going to be all real numbers. So I want you to write this, because if you write it, you'll remember it. Domain is all real numbers. All right, we're going to talk about this last sentence after we do an example. So let's do an example. We're going to make a table of values, and this is how I figure out on what numbers to put for my X. Okay, pretend like you're standing at the origin, and you walk one space to the right. Okay, your first point was 0 because you were at the origin. You walk one space to the right, and your X is 1. You walk another space, and your X is 2. You walk a third space, and your X is 3. All right? Now, you're going to walk backwards. You're going to walk to the left. Your X is -1. You're going to take another step, -2. You're going to take another step, -3. So that's how I figure out which numbers to put into my table is you're standing at the origin, do 3 to the right, and do 3 to the left. All right? So that's how we're going to pick them. All right, so now we're going to plug them in. I like to start at the 0, but I don't always do that, but I am for now. So I'm going to go plug in a 0, 2 to the 0, anything to the 0 is 1. All right, let's go to a positive number. What's 2 to the 1? That's 2. All right, keep going higher. 2 to the 2, that's 4, because that's 2 times 2. All right, 2 to the 3. 2 to the 3 is 2 times 2 times 2. So that's going to be 8. All right, let's go ahead and graph those and see what our graph's starting to look like. 0, 1, 1, 2, 2, 4, and 3, 8. So far, it's kind of reminded me of the coronavirus because it started out as low numbers, and it looks like this is rising. But actually, the coronavirus is going to be more like an inverted or a reflected parabola, where the number of cases increases, but then it should hit a plateau, and then they should start decreasing, especially after we find the antidote. Okay, back to our problem. All right, so now we're going to go fill in our negative numbers. So remember, when you work with negative exponents, you don't really want to have negative exponents. So 2 to the negative 1 is still 2 to the negative 1. You can't just erase it. But I'd rather be around positive people than negative, so remember, we don't want negative exponents. So what you're going to do is you're going to take the 2 to the negative 1 and you're going to bring it down to the denominator. Now, when you do, you're still leaving a 1 up in the numerator. Okay? Just think of it as this, 1 times this. It's still sitting there. When you bring the 2 down to the denominator, that negative 1 becomes a positive 1. And so that's really just going to be 1/2. All right, so let's try 2 to the negative 2. And let's see what happens with that one. So 2 to the negative 2. Put it over 1. Leave a 1 up in the numerator. Take it and bring it down into the denominator. And when you do, it's 2 to the 2. So 1 over 2 squared. So that's 1 over 4. So that's 1/4. All right, I think I can easily change this to a 3. Bring it down to the denominator. Turns into a positive 3. 2 to the third is 2 times 2 times 2, which is 1/8. All right, you're going to find these are going to be a little bit interesting to graph. All right, so let's start with the easiest one, the negative 1, 1/2. So negative 1, 1/2 is about right here. Negative 2, 1/4. Negative 3, 1/8. All right, let's connect our dots. This is what an exponential function looks like. Okay, right now you feel like this is the coronavirus. Not many people, and it's increasing. That's what you feel like. So anyway, that's a exponential function. Now I want to explain to you what an asymptote is. I want you to get a different color pencil, pen, writing utensil, I don't care. And I want you to do a dashed line on top of the x-axis. That is an asymptote. An asymptote is a line that a graph approaches as the x or the y increases. All right, so as I'm going from left to right, we see that this is an increasing, okay? But if you look at it going from right to left, you see that the exponential function is gradually getting closer and closer and closer to that line, but it's never going to touch that line. That's an asymptote. The line that the graph approaches and gets closer and closer and closer and closer to, but it never touches it. All right, so we already said that the domain is going to be all real numbers. So I'm going to write all real numbers. All right, our asymptote, let's look at it. Our asymptote is a horizontal line. So I taught my classes, HOI. H stands for horizontal line. 0 stands for the slope is 0. And Y stands for it will be in Y equals form. So the asymptote is horizontal. So go down here where you see the word asymptote and put Y equals. Now look at the asymptote. And in that asymptote, tell me what Y equals. 0. So like this point right here, that's 1, 0. This point right here is 2, 0. This point right here is 3, 0. So what does Y equal? It equals 0. All right. When you figure out your asymptote, it's going to help you with your range. So whatever your asymptote is, you're going to rewrite it without the equal sign. And you're going to say, okay, go look at your chart, your table. Look at all the Y's. Are they greater than 0 or are they less than 0? And they are greater than 0. So that's what you're going to put. All right, let's go to our next question. I hear a frog ribbiting or whatever outside my window. I don't know if you heard it or not. All right, B. Okay, I'm going to choose my points. 0. This time I'm going to put 1, 2, 3 above it, and -1, -2, -3 below it. It doesn't matter. If you look at the one that I just did here, I did it in the reverse order, but I'm still using the same x coordinates. All right, I'm just going to start at the top this time, and I'm going to do 1/2 to the third power. Now remember, that's 1 to the third and 2 to the third, okay? So that's going to be 1 over 8. And let's go ahead and graph it. 3 and then 1/8. All right. Now we're going to substitute 2 for x. So 1/2 squared, that's 1 squared, which is 1, over 2 squared, which is 4. So that's 1/4. Let's graph that one. 2, 1/4. All right, now we're going to do to the 1. So 1/2 to the 1 is just really 1/2. All right, let's graph that one. 1, 1/2. As you can tell, I'm starting to gradually increase as I'm going from right to left. All right, I'm going to plug in a 0 there. Anything to the 0 is 1. So 0, 1. I'm on the y-axis for a little bit. All right, now we're going to plug in a negative 1. That means 1 to the negative 1 over 2 to the negative 1. So you switch them and you do 2 to the 1 over 1 to the 1. And then I can just erase the 1s, and that's going to be 2. So let's graph that one. Negative 1, 2. All right, let's do the same thing to negative 2. Easier if I erase it and kind of start over. So 1/2 to the negative 2 is really 1 to the negative 2 over 2 to the negative 2. Both of them are to the negative 2 power. So we're going to switch them. And it's going to be 2 to the 2, which is 4, over 1 to the 2, which is 1. So that's going to be 4. All right. Our last one for this problem is going to be 1/2 to the negative 3. So 1/2 to the negative 3. It's going to be 1 to the negative 3 and 2 to the negative 3. Switch places. 2 to the third over 1 to the third is 8 over 1, which is 8. All right, let me go graph those two. Negative 2, 4, and negative 3, 8. Let's connect the dots. Always put arrows at the end. And you can see it's getting closer and closer and closer to that same line, the asymptote, but it will not touch it. So let's do our dashed lines. We're drawing the asymptote right now. Asymptote has arrows at the end of it too. Let's go ahead and write what the asymptote is. It's a horizontal line and it's on the x-axis, so y equals 0. That helps me with my range. Y is greater than 0, because if you look at your y's here, what are they? They're all greater than 0. Don't forget your domain is all real numbers. All right, if you want to just go ahead and start working on the next one on your own, I'm here if you need me. You could pause me or mute me and then look back up and see if yours is right. 0, 1, 2, 3, negative 1, negative 2, negative 3. 3 to the 3 is 27. 3 squared is 9. 3 to the 1 is 3. 3 to the 0 is 1. 3 to the negative 1. I'm going to put it over 1. I'm going to flip it. And it ends up being 1/3. 3 to the negative 2 will be 1 over 3 squared, which is 1/9. 3 to the negative 3 is going to be 1 over 3 to the third, which is 1/27. And now I'm going to graph it, but before I graph it, I'm going to go ahead and go down here. The domain is all real numbers. I'm going to go ahead and draw my asymptote before I get all those points on my graph. I'm not doing it in the same order as I did a while ago, just to show you. You don't really have to. My asymptote is y equals 0. It's not always that, but it is right now. So y is going to be greater than 0. And if you look up in your table, check. You're right. All right, let's go graph it. 3, 27, 2, 9, 1, 3, 0, 1. -1, 1/3, -2, 1/9, -3, 1/27. Connect your dots. You can see as you go from left to right that this is increasing. So this one's increasing. The one right above it is increasing because you look at it like you're reading from left to right. So B, the second one we did from left to right, was decreasing. Maybe somebody was looking at their weight loss or something, you know. All right, and then the last one on the front, let's do this one. Gotta see what it is, see if it's increasing or decreasing. I'm going to go ahead and put my domain as all real numbers because I do know that. I'm going to go ahead and put my real numbers in there. 3, 2, 1, 0, -1, -2, -3. 1/3 to the third. That's going to be 1 to the 3 over 3 to the 3, which is 1/27. I'm going to graph it 3 and then barreling up a little bit. All right, now we're going to do to the 1/2. So that's going to be 1/3. I didn't mean to say to the 1/2. I meant to say to the 2. Sorry. It's going to be 1 squared over 3 squared, which is 1/9. So I'm going to graph that 2 and 1/9. All right, now we're going to do to the 1. That's just going to be 1/3. So I'm going to write that in my table and graph that 1 to the 1/3. All right, 1/3 to the 0 is going to be 1. So 0, 1. All right, now I'm going to do 1/3 to the -1. So that's 1 to the -1 over 3 to the -1. Switch places and get rid of the negative. So the 3 comes up and the 1 comes down. So that's just 3. So -1, 3. All right, now we're going to do it to the -2. So we're going to do 1 to the -2 over 3 to the -2. Don't forget your numerator and your denominator are both to the power of -2. So we're going to switch them, and we're going to have 3 squared in the numerator and 1 squared in the denominator. So we'll have 9/1. So that's 9. So -2, 9. All right, and then we're going to have -3. So when we put -3 there, when we switch them, we're going to have 3 to the 3 on top and 1 to the 3 down bottom. So 27/1, which is 27. So -3 and then all the way up to 27. Before I connect my dot, I'm going to go ahead and go draw my asymptote because sometimes it's hard to draw it when I have that line sitting there. So I'm drawing my asymptote. This is the line that the graph will gradually try to touch but never touch. All right, now I'm going to connect my dots and do my exponential function. It gradually gets closer and closer and closer but never touches. So that's a decreasing, right? So think about as you read from left to right, what's happening to the graph? It is decreasing. All right. All right. So my range is going to be y is greater than 0, and my asymptote is going to be y equals 0. All right. Go ahead and go to your next page. And we're going to talk a little bit about exponential growth. All right, you guys. So we're on the back now. Exponential growth and exponential decay. Now we've kind of already gone over this. You just don't know it. All right. So whenever I was saying that a graph was increasing, okay, that's exponential growth. Okay, as you go from left to right, just think you read from left to right, so you look at the graph from left to right. So as the value of x increases, the value of y also increases. So I'm going to go back to a previous one. We're going to look at C. As the value of x increases, okay, I'm going up because it increases. Look what's happening to the value of y. It's increasing. Let's look at our other one. A. As x increases, now look, I'm just looking at the numbers. As the numbers get bigger for x, guess what? The numbers get bigger for y. So it's going to be opposite for an exponential decay. So let's look at B. Let's look at it for a minute. I'm just looking at the table. As the x value increases, look what's happening to the value of y. It's decreasing. That's why this is a decreasing. You look at it from left to right, and it goes down. All right, look at the one below it, D. We know this is decreasing because we set it, but I want you to look at the table. As the x values increase, as I go up, they're getting bigger and bigger and bigger. What's happening to the y values? They are decreasing. That's why this is a decreasing picture. So that's the difference between exponential growth and exponential decay. So just draw a little sketch of exponential growth like I did right there. Okay, and what I want you to put beside it, I want you to write growth. I want you to write increasing. I want you to put that the A has to be greater than 0 and the B has to be greater than 1. Okay, the A has to be greater than 0. We already know that A cannot be 0, but it's going to be greater than 0. And the B is going to be greater than 1. Now, if we look at the page before and we go look at B, because the A's for all these was 1, okay? But your B has to be greater than 1. So look at this one. Here's B. Isn't that greater than 1? Look at this one. Here's B. Isn't that greater than 1? All right, let's look at the exponential decay. What I want you to do for the exponential decay is I want you to draw just a little sketch of what a decay would look like. So this is decay. I want you to write decreasing. That's kind of easy. Decay, decreasing. I want you to put that A has to be greater than 1, just like the exponential growth, the exponential decay. A has to be greater than 1, but B is going to be less than 1. All right, so for an exponential decay, you did a little sketch. You wrote decay, decreasing. A is greater than 0. We already talked about how A cannot be 0, but A is greater than 0, just like in the exponential growth. But B is less than 1, whereas in the exponential growth, B was greater than 1. So let's go look at these. Now remember, the A is all 1. I'm looking at a decreasing one. Let's go look at B. I'm going to highlight it in pink. Look, 1/2 is less than 1. Look at B. 1/3 is less than 1. So that should make total sense now. Exponential growth and exponential decay. All right, so let's go down here to the directions. It says determine whether each function is growth or decay. We're going to go do all that first. Now, you're looking at the number that's you're looking at the number that's the base, and it has x for an exponent. That's what you're looking at, okay? Because we already know that A is greater than 0 for both of them. So we're going to focus on what's different. So I'm going to circle it in pink. When B is less than 1, it's a decay, right? All right, neon green. When B is greater than 1, it's a growth. All right, so let's look at this first one. I'm looking at the base, 0.95. So you tell me, is 0.95, is it less than 1 or is 0.95 greater than 1? Think of it as money. Obviously, it's less than 1. All right, so which one is the less than one? Think about less than, decrease, decay, okay, less than. So we know that this is going to be an exponential decay. So I'm going to write decay. And if you had to explain, well, why do you know this? Well, because 0.95 or 95 hundredths is the base, and the base is less than 1. The base is less than 1. All right? All right, let's go to the next one. Go to the base. It's the one that has the exponent. Now, is that number right there greater than 1 or less than 1? It's greater than 1. So what is it going to be? It's going to be a growth. All right, we're going to the base that has the x as the exponent. Is 1/2 greater than 1 or less than 1? Less than 1. So what is it? Growth or decay? It's decay. All right, let's go to the next one. This one might be tricky. You might look at 5/4 and think, oh, it's a fraction, it's less than 1. Oh, no, it's not. 5 over 4 is 5 divided by 4. 4 goes into 5 one time with 1 left over, 1/4. That is bigger than 1. That is an improper fraction when the numerator is bigger than the denominator. It is bigger than 1. So that's really 1 1/4. So B is greater than 1. So it has to be a growth. All right, let's look at E. We're looking at the base, the one that has X as an exponent. Now, you see on this one, you're like, duh, it's just like the one we just did before. It's a decay. All right, let's go to the next one. Now, 3/2. You tell me. Is 3 over 2 greater than or less than 1? It's greater than 1. So this is going to be a growth. You don't have to tell me like I showed the work up here. I was just explaining to you why. Okay, the last part of this lesson, go back up to the box where it talks about the y-intercept. I'm going to erase while I read you about the y-intercept. The y-intercept occurs when x equals 0. So let's go back up to right here. Let's look at this one. This right here is the y-intercept. If I was going to write that ordered pair, that's 0, 1. The y-intercept is when x is 0. Okay, that should make sense. All right. Therefore, the y-intercept is always 0a. Y-intercept. Now notice, look, the y-intercept will be whatever a is. Remember, this is y equals a b to the x. The b part tells me whether it's a growth or a decay. What's it going to be? Get it? And the a part tells me what the y-intercept is. All right? So the second part of the instruction says, what is the y-intercept? Well, look, there it is right there. But we're going to write it as an ordered pair. We're going to put 0, 12. That's the y-intercept. If you write y-intercept, you're going to understand the concept and remember it better because you're hooking that file to a file in your brain. That's just the way it works. We hook our files to things that are familiar to us. All right, let's go to B. All right, this is the y-intercept. So I'll write it 0 and then 0.25. Now I'm okay with you putting 0.25. Either one. It is the y-intercept. All right, C, we're looking here. That's the y-intercept. The y-intercept is 0, 18. That's the y-intercept. All right, D, what is in front? Well, it doesn't look like there's anything there, but there is. There's always a 1 sitting there. That's what was going on with these problems here. There was a 1 in front of every single one of these. We just didn't really think about it or talk about it until now. So your y-intercept is 0, 1. That's your y-intercept. All right, look at E. This is our B. This is our A. Our A is our y-intercept. So that's 0, 2/3. Y-intercept. All right, let's look at our F. This is our B. This is our A. A is y-intercept. So you're going to put 0, 1/6. That is your y-intercept. Now, if I asked you to go explain the growth and decay for me, you could go back and do this. So I'll do it in purple. B is less than 1. Okay? For A, now let's look at B. B is greater than 1. I'm circling it and then I'm saying it. For C, B is less than 1. For D, I'm circling it. B is greater than 1. Go to E. I'm going to circle it. B is less than 1. And then F, I'm going to circle what B is. B is greater than 1. All right, well, that concludes today's lesson. This is part 1 of 7.1. And you're going to go upload your worksheet and do your worksheet for this one. All right, you guys, thanks. See you tomorrow. Bye.